Hello and welcome to this keynote session, forming part of the 12th Annual Analysys Mason Telecoms Summit. My name is David McElroy, and I work as part of Analysys Mason's online events team. Now, you may have already watched some other sessions leading up to this one. However, I just wanted to remind you of a few points that will help you to get most out of this and all other summit presentations. Firstly, remember that all sessions are available on demand, meaning that you can access them in an order and at a time and a date that suits you. We have a selection of keynote and breakout sessions for you to choose from, and you can access all of them via the event homepage. Once you have entered your chosen session, you have the ability to connect with our presenters, access and download useful resources, and submit questions. As these are on-demand sessions, our presenters will pick up your questions and respond to you directly via email in the coming days. And once the session has ended, you'll be automatically redirected to the event homepage where you can select another session. Now, I have the pleasure of introducing Caroline Gabriel and Caroline Chappell, both research directors at Analysys Mason. So I believe Caroline Gabriel is going to kick us off. So Caroline, over to you when you're ready.
Thanks so much, David, and thank you everyone for joining. The telecoms industry is starting to talk about 6G at a time when 5G has hardly been monetized. At least as it's been implemented to date, 5G represents business as usual. As for 6G, we certainly don't know what it will look like technically, although there's already significant money and brainpower focused on answering that question. But to be of real consequence and not simply another radio upgrade, 6G must change the way the world works. It must be fully converged with the cloud, which has been changing our world while connectivity has largely remained conventional. It must support the metaverse, which is almost as undefined as 6G itself, but which represents the vision of a new way of working and living. In our presentation today, we do not promise to define what a 6G metaverse may look like, but we want to discuss the building blocks that need to be put in place in the near term to enable it, and the entirely new business opportunities that it would create for network deployers and service providers. So over to you, Caroline.
Thanks, Caroline. So as humans, we're 3D beings. We intuitively understand the world in 3D and find the 2D world harder to visualize and navigate. In the pandemic, 2D tools and capabilities such as Teams and Zoom came to our rescue, but we are all relieved to be back experiencing each other and the world in 3D. So it's no coincidence that the metaverse, which after all has been around as an idea for decades, has been gaining so much airtime and investment post-pandemic. There can only be one metaverse, one seamless rendering of the 3D internet, which encompasses and integrates in an interoperable way multiple independent 3D virtual worlds. However, the metaverse is not emerging from a single direction. And in fact, we believe there are two and possibly even three distinct facets to current metaverse development. For chapter and verse on this, we refer you to the research work being undertaken by our colleague Martin Scott, who is our resident expert on the metaverse. But for simplicity today, we've characterized these developments as the industrial metaverse and the consumer-facing metaverse. There's, of course, a blurred line between the two as they draw on common technologies and have similar connectivity demands. And they will eventually, we believe, become contiguous, interoperable worlds in the metaverse continuum as a result of the inevitable technology-led social changes that will accompany metaverse use. Now, on the right-hand side of the slide, we show the industrial metaverse, or overlay metaverse, as some call it, where a bunch of technologies, including digital twins, AR, VR, sensors, real-time streaming data, AI and analytics, and 3D computer-aided design engines are being brought together to create a data-driven simulacrum of physical industrial environments. Humans can immersively enter and manipulate these virtual environments with their actions fed back into the physical environment through robots, cobotic suits, or programmable interactions. The key driver behind the industrial metaverse is the need across manufacturing, energy and logistics sectors to optimize the visualization, building, operation and management of real-world objects and processes, everything from cars and white goods to ports and production lines. Why? Because in a physical world of contested resources and rising costs, there's an imperative to reduce waste and to optimize the production and delivery of physical goods. As Rev Lebaradi, NVIDIA's VP of Omniverse and Simulation Technology, recently pointed out, a staggering 30% of the production process for any physical product is waste. Now, on the left-hand side, we have the consumer-facing metaverse, the superset of 3D virtual worlds that provide new immersive experiences for social, entertainment, educational, health, and commerce purposes. Here, the driver is economic growth, the seemingly limitless opportunity to establish a completely new economy beyond the physical world by selling people experiences and goods they can't have IRL, in real life, and which they'll be prepared to pay for. We're at the very beginning of understanding how new business models will work in 3D virtual worlds, and the next generation of born in the metaverse equivalents of Facebook, Amazon, Google, and ByteDance have yet to appear. But that's not stopping the investment community placing bets in order to find them. And Caroline, I believe you've been looking into this.
Yes, indeed. Of course, it's very early days to understand just how much investment will go into the metaverse. And there are very different figures being discussed, but all of them represent multiple trillions of dollars by 2030. Our initial estimates are that the metaverse will generate 4.43 trillion US dollars of economic value by that date. And that's split between about 1.9 trillion in financial investments and infrastructure capex, including 6G and cloud, and about 2.5 trillion in metaverse-related revenues. The point is, whatever the specifics of the figures, the point is that stakeholders and investors are already making their plans, money is flowing, and new developments are underway to support these new user experiences. But they will have to wait for the new network to happen if they're to come to fruition.
Ah, the new network. I think that's on the next slide.
Yeah,
we've started to discuss the impact of software defining this network at last year's summit. And this slide will look familiar to those of you who attended our session then. But there's a critical difference this year as we link the new network with metaverse developments, both industrial and consumer facing. Look closely, and in this graphic, we're now showing that in the metaverse, every physical object or thing will have a digital counterpart, a computer-generated twin built from data streamed from sensors attached to the physical object it's replicating. And this data needs to be collected, analyzed through AI algorithms, and delivered by a vast compute, storage, and connectivity infrastructure that isn't yet in place. There will also, of course, be virtual worlds that are entirely imaginary, better than the physical offices we go to work in, or the physical classrooms in which we learn, and potentially more wonderful and more liberating than the physical world in which we socialize and play. These worlds will also be constructed from computer code and involve the downloading and streaming of data. The more amazing to experience these worlds are, the more data will be required to render them and the more AI will be used to deliver them. And we're only at the very beginning of imagining what the network and edge cloud infrastructure needed to support these rich, interoperable, massively scalable and persistent 3D virtual worlds looks like.
Yes, indeed. And last year, we talked about 5G evolution. But here we're talking about a brand new architecture. The evolution of radio standards from 5G to 6G will be one enabler of that, but we believe it will be a small part of the broader architectural transformation. The reason we think this is necessary is because the 5G network has so far only addressed a fraction of the emerging opportunity of the 3D internet, even as it exists at this early stage. To date, with a very few exceptions, the business models that operators have built on 5G have been business as usual. They've centred on offering faster speeds and greater reliability for mobile broadband, seeking to boost ARPU incrementally or just maintain it, while improving the cost of delivering large quantities of data. And for some operators, indeed probably many operators, this model will remain the basis of their monetization strategy throughout the 2020s. That may be adequate in some scenarios, if operators achieve massive scale through consolidation, for instance, if they target markets that still have significant growth, if they extend their wireless broadband network into fixed wireless or wholesale opportunities. But in competitive and developed markets, there will be limited opportunity to pursue growth or scale. Plus, there are large groups of users whose demands are just not being met. So the short-termism of the business as usual model is already being seen around the world. ARPUs and revenues are already falling in South Korea, for instance, that most advanced of mobile economies, a small 5G boost having lasted only for 2 years. We've argued since the dawn of 5G that the build-out can only be justified if operators expand into significant new markets and revenue streams, and Caroline has outlined where these are starting to exist in the enterprise and industrial front. This was mooted for 5G when it was being defined. Grand goals were set out for a network that would support a wide diversity of enterprise and industrial use cases, some of them currently impossible with other available networks, and a network that would deliver significant cost and energy efficiencies and brand new user experiences. Most of that has not really transpired, and if operators do not start to put the foundations of that vision in place now, the rapid evolution of user requirements will outrun 5G developments, making the 5G generation potentially redundant. We do believe that the 3D internet, as Caroline has set it out, will require an architecture that goes far beyond what 5G can deliver today, even if it is implemented optimally. 6G could be developed entirely separately from the 5G ecosystem and be primarily driven by the cloud and internet communities, and that would leave telcos as bit players. But we believe that telcos can be proactive now in developing and evolving the capabilities of their platforms, and so ensure that the 6G platforms and business models do become evolutions of what they put in place today and leave them with a central role in the chain. But to keep telcos central and relevant to the future internet model, we see a roadmap developing that will take them on the challenging ascent to the eventual summit of 6G and 3D internet. That ascent splits between 2 routes, which we're going to describe in the next few slides. As this slide depicts, both routes are challenging, and they're primarily differentiated by timing. The first route up the mountain, from the base camp of current mobile broadband, takes us via new markets and industrial services, which are emerging now and can be initially enabled by 5G technologies. This is the industrial overlay metaverse that we saw on the left hand of the previous slide, and it enables telcos to monetize 5G and edge in new ways as soon as possible. We're calling this the industrial connectivity platform. The other route is to stay at the base camp of mobile broadband, leveraging conventional models until later in the 2020s, and then to embark on a direct ascent towards the more transformational architecture of 6G. Telcos that choose this route must put enablers in place gradually as they emerge, but they will only activate them commercially when monetization opportunities can clearly be seen in the 3D internet. And we're calling this architecture the Universal Digital Fabric. Looking first at the industrial connectivity platform, this is a first step towards the full 6G 3D internet platform. As Caroline has explained, the industrial platform is an overlay metaverse, which uses APIs to open up the network to applications so that service providers and enterprises can directly program the connectivity they need, create use case specific network slices, and make maximum use of the new features in 5G on its roadmap. This will require new localized metro and campus architectures, and those will often be run by private network operators, as our colleague Michelle McKenzie will describe in her session. Increasingly, those enterprise networks will be converged, relying on fixed mobile Wi-Fi and specialist connections working as a seamless whole. As I described on the previous slide, this is what was envisaged to be transformational about 5G in its pre-commercial days. But so far, with a few exceptions, operators have struggled to establish a sufficiently strong business case, and many investments have remained local, specific to one enterprise or location, and often 4G based, with limited interworking between different networks to serve a whole sector or supply chain. A more unified 5G industrial connectivity platform is essential to drive significant new revenues, and it is in reach, at least in its first iteration, using current and emerging network and cloud technologies. operators can establish a strong roadmap for the ICP starting today. The foundations of the ICP are reflected in the next 3 releases of 3GPP standards, which are collectively called 5G Advanced. These will build on the work of the first releases, 15 to 17, but with a keener focus on industrial applications in all their diversity of requirements. Important developments that are designed to support a wide range of industrial use cases optimally include simplified and therefore more cost-effective implementations of ultra-low latency communications, which support near real-time response, guaranteed reliability, and deterministic connectivity. All these capabilities are critical to business-critical applications in industrial settings and to supporting meaningful service-level agreements, and this has previously been possible only with fibre or proprietary protocols. Other examples include hyper-accurate 5G positioning to support advanced vehicular and robotics operations, seamless integration with fixed Wi-Fi and non-terrestrial industrial networks, the ability to connect, provision and manage hundreds of thousands of devices and sensors, and AI-driven dynamic optimization of the network to adapt to changing traffic and latency requirements. All these capabilities implemented together will create a robust, near real-time infrastructure on which many industrial use cases can run, fully integrated with one another, despite having entirely different connectivity needs. While industrial 5G is currently defined in the famous triangle of use cases may risk being ready out of step with real enterprise requirements, the enablers are emerging quickly to bring it back into line with industrial demand, while putting the pieces in place for a more radical 6G reworking in future. That future-proofing will lead us to the next phase, which Caroline will now describe.
Thank you. So ultimately, what will be required to support the needs of the metaverse, which is a superset of computer-generated 3D worlds, whether industrial or consumer-facing, is a network that's radically different from what's in place or is even on the 5G roadmap today. We're calling this the 6G network the Universal Digital Fabric, and it's the summit of the mountain, as you can see. Now, I'm now going to use a lot of buzzwords to describe the UDF, but please bear with me. We envisage the Universal Digital Fabric as an AI-mediated, common but hyper-distributed control plane that runs across network domains that are siloed today, including wireless access networks, but also fixed access and transport networks. This completely software-defined and cloud-based control plane will be metaverse-aware, which is another way of saying it will be application-aware, since the metaverse as a computer-generated entity will consist of millions of microservices and applications. All of these applications, including digital humans or avatars as applications, will need to be routed dynamically and continually for execution in optimal locations, or even processed in flight en route to destinations. So the UDF will need to be able to shapeshift depending on the needs of metaverse applications and the underlying infrastructure available to it at any point in time. It needs to shapeshift between being a routing control plane and a compute control plane. And to build it, we'll need new technology developments at every level, new networking and data flow protocols, new power-efficient chipsets, new hyper-converged approaches to hardware, new compute paradigms, and advances in AI, to name a few.
Caroline, this doesn't sound like just another network upgrade. It sounds like a dramatic change to the network control plane, where it runs and what it does. We can't know yet exactly what the UDF will look like. We can only posit what it needs to do in order to meet what we see as the needs of the future. But it does beg the question, why do we really need this UDF?
Well, we'll need the UDF, Caroline, precisely because it has to support the completely new, immersive and customer-delighting experiences I've talked about. The ability to walk seamlessly through portals into 3D virtual world after 3D virtual world, bringing your virtual friends with you. The ability to contribute to virtual worlds and their narratives by building and submitting new components of it yourself. So those 3D virtual worlds will themselves be continually changing as a result of potentially millions of collaborations. the ability to experience those worlds from novel and personalized perspectives. If you think about it, all this will require connectivity that is continually adapting in real time and that needs to shift massive amounts of data around with consistently low latency. And it can't be as fragmented a network as you've just talked about and described in the industrial connectivity platform. Today, we nail up network infrastructure in rigid ways that are difficult to change. It can take months to stitch together low latency connectivity between geographic locations. The UDF will need to be an environment where connections can be instantiated on the fly to support the massive freedom of action people will have in the metaverse. It will need to support interactions that are spontaneous rather than predictable. It'll need to respond dynamically to virtual events that many more people will flock to than can do so in real life. It's clearly not possible to deliver the connectivity features the metaverse needs today with 5G or with any network architecture we've ever known.
But the latency of the network needs to be predictable and deterministic, and as low as the law of physics will allow, at an affordable price. And anything will need to connect to anything in an unpredictable, spontaneous metaverse environment without the hindrance of disparate technologies. So the UDF control plane basically has to be the fabric that joins them all together.
That's right. And the fabric is an important word here because it's probably going to be realized as a collaboration of AI agents, incorporating what's becoming known as ambient intelligence. The question is, though, how will the UDF evolve?
Yes, well, let's consider that question. Already in the early 5G era, we're seeing changes in the telecoms value chain that will lay the foundations for the 6G UDF and all the use cases and business opportunities it will enable. Today, we're looking at the chain in 4 layers, which we'll describe briefly here: physical infrastructure, aggregated infrastructure, service platforms, and applications. At the current time, physical networks and infrastructure are largely deployed and owned individually by the same organisations that provide services on top of them. However, there are moves to increase the economies of scale and total cost of ownership efficiencies of physical networks through aggregation, sharing and wholesaling, trends that have already taken root, of course, in the cloud infrastructure world. In the networks, aggregation is already starting. We see it in towers, subsea cables, long-haul transport, and even some shared mobile access networks. But this process will need to be significantly accelerated to improve the economics of building out a network with completely new capabilities and with ubiquity, and to make more efficient use of resources to save cost and energy. The need is not to build more capacity in most areas. In fibre networks, on average, only 1.5% of capacity is regularly used, as our colleague Rupert Wood will describe in his session. But we need to use resources far more efficiently. Aggregation will be further driven by market forces that are expected to intensify in a time of economic crisis. So we're seeing consolidation, the flight of cash to physical infrastructure, fibre M&A, and so on. Furthermore, APIs will enable massive infrastructure to be used by local telcos and enterprises. We're seeing the very beginning of APIs emerging through standards such as Open RAN and fixed 5G, which will enable this aggregation at scale. There are commercial opportunities for telcos to be aggregators as long as they API enable their physical assets, or to decide to rely on third-party API enabled infrastructure and focus their business model on the service platform. On which point, over to you, Caroline.
Sure, because as the 5G access and indeed the transport network are increasingly implemented as software that runs on cloud infrastructure, and as that cloud infrastructure is deployed more ubiquitously, for example, in carrier-neutral facilities as well as deeper into an operator's own geographic footprint, we're seeing the rise of these of software-defined cloud-based networks as service platforms. A network as a service platform enables network functionality to be instantiated on demand in locations that best suit customers and applications, and its network functionality can be directly accessed by customers themselves through APIs and cloud tooling. The routing and other capabilities of a service platform can be very rich and can augment in software the limited capabilities provided by underlying physical networks. We're seeing early examples of service platforms from multi-cloud connectivity providers in the enterprise market, and Gurkhan Yeat will be talking more about this in his session later. But the 5G network as an open programmable service platform that developers can gain access to is on operators' roadmaps, but very little has been achieved yet in today's business as usual environment. That's partly because most operators' 5G networks are still in the process of being virtualized and deployed on cloud infrastructure, and partly because, as our research and this slide shows, there are very few applications out there at the moment that absolutely need the features that 5G can provide. So at this level of the value chain, 5G service platforms are in their infancy, and developers would have very little incentive to use them, even if they did exist. But what changes, Caroline, when it comes to the industrial connectivity platform?
Yes, as we move to that industrial connectivity platform, the physical infrastructure layer actually becomes more fragmented, as you can see on the slide, as localized networks increasingly converge with edge cloud proliferate. We're already seeing a significant increase in enterprise private cellular networks, as Michelle Mackenzie will explain, as well as small cell build-outs to support smart cities and so on. So there'll be many opportunities for local infrastructure as different enterprises increasingly need specialized, optimized, and often private connectivity, especially where use of the converged network becomes a competitive differentiator, not just an efficiency driver, driving better delivery times, improved quality, and so on. Some telcos will expand in private networks, but in some markets, private networks will be deployed and run by a new set of providers. So the aggregation layer will be even more important to establish the global frameworks to link the localized networks into a bigger whole, and that in turn will improve return on investment in all layers and enable new services such as dynamic slicing. This layer will not just be wireless. Convergence is a key requirement at local and aggregated infrastructure levels to support new use cases and processes in the most resource-optimized way. To enable truly ubiquitous coverage for logistics applications and so on, and also to support global organizations and business chains, the infrastructure layers will include fixed, mobile, satellite, subsea, and many other types of connectivity. And that in turn will provide new opportunities for certain operators. For instance, we're seeing the activities that Telefonica has recently talked about in the satellite arena.
But even the largest aggregators of physical infrastructure are unlikely to connect 100% of the destinations a service provider's range of industrial customers is likely to want to reach. So we expect an explosion in the numbers of players using the aggregators' APIs to build software-defined network-as-a-service platforms on top of the physical cloud, edge, and network infrastructure they aggregate. Now, these service platforms, or industrial connectivity platforms, will provide network control planes that can spin up end-to-end deterministic connectivity, or slices, across different access and transport network underlays between any location an industrial application needs to operate across. They'll also provide developer-friendly APIs and software development toolkits that will enable developers to program 5G Advanced and other network features into their cloud-native industrial application pipelines. Now, we predict that such capabilities will spark a virtuous circle in the development of industrial applications such as digital twins and AR/VR applications that depend on the low-latency streaming of data and which therefore need the support of deterministic virtual networks with a customized quality of service and security features. However, for this business model to work, it's clear that a huge amount of developer education is needed. There's no point in launching an industrial connectivity platform with a software development kit if developers don't know it's there and won't use it. And while the service platform level of the value chain is potentially lucrative, it also poses a risk for traditional 5G operators. It's going to become easier for cloud-capable, developer-friendly new entrants to build programmable network-as-a-service platforms on top of the aggregator's physical underlays, and they'll compete with operators for emerging industrial metaverse-related connectivity revenue. Now, in the Universal Digital Fabric, I think things change again, Caroline, don't they?
Indeed, they do, quite dramatically, in fact, in our view. In the Universal Digital Fabric, we see new opportunities emerging in each layer, though in the aggregation and service platform layers, these will increasingly be consolidated in the hands of a few players. And for telcos, the opportunities in all the layers will be hotly contested with a diversity of competitors. 6G infrastructure in the bottom layer will become hyperdense and hyper-distributed, with connectivity hubs fully converged edge compute and deployed in every corner, right into homes, cars, and so on. This may be a telco play, comparable to the installation of home Wi-Fi and broadband, for instance, but it will go far beyond that, because each tiny connected edge will not just support services for that user, but be part of the global fabric. That fabric will be underpinned by massive aggregation of underlying global physical infrastructure, such as fibre backbones and huge data centres. Physical infrastructure will be increasingly aggregated, therefore, and this will be essential to achieve the scale to support a ubiquitous global metaverse and to match network scale to cloud scale as the two converge. This will be achieved by a few hyperscale operators who may not be the current cloud hyperscalers, or who may be, but not by individual telcos. Most telcos will stay in the last few miles of connectivity or change to be pure service providers. We'll also see advances in material science and semiconductors at this point, which will enable unprecedented levels of reconfigurability that will make the inside-out model and the user-centric model things of reality, with every small device projecting its connectivity into the fabric via APIs. Caroline, do you want to tell us more about this universal fabric?
Yes, so finally, by the time we get there, and the need to support the future of the metaverse as we envisage it, the concept of individual fragmented service platforms, and even the distinction between an industrial connectivity platform and separate service platforms to support connectivity for consumer-facing applications will disappear. The UDF can be thought of as the software-defined counterpart of physical aggregation that Caroline mentioned a couple of slides ago. Now, this software-defined and AI-mediated aggregation layer will provide seamless any-to-any intelligent routing, including deterministic routing, across different infrastructure types and locations from cloud to edge. It will be able to instantiate networking and compute dynamically at whatever scale, with whatever features that applications need, wherever they need them. Because as a fabric, it will hold a catalogue of where in the infrastructure, where in that aggregation of infrastructures, plural, the relevant capabilities and compute locations reside. And it will, in other words, the UDF will allocate capacity to locations dynamically on an on-demand basis, may even spin up features and capabilities in those locations, and the network will reshape itself around metaverse users and objects as they need it. But the big question is who will provide it. If it's an aggregation layer, there are likely to be very few service providers with the scale and the capabilities to build and operate it. Will the same few providers of physical aggregation also provide the UDF, or is the UDF such a different type of business that it represents a completely new opportunity for a software and cloud-capable service platform provider? Now, the alternative to aggregation is a standards-based federation of operator, software-defined, and AI-enabled control planes. But although standardization is a time-honored tradition in our industry, operators will have to move faster and become far more innovative than they currently are in order to build a federated UDF. So do we have any ideas of where operators currently are on their journey towards the industrial connectivity platform and UDF, Caroline?
Yes, I think we're starting to see some general trends among operators. We expect many of them just starting out on their 5G journeys to continue along the business as usual path for years to come. And as infrastructure owners, they can still serve the growing demand for densified networks and capacity without venturing further up 6G value chain just yet. However, if these operators do want to provide network capabilities in future to support the metaverse and contribute directly to the UDF, they will have a steep climb at the end of the decade as both become better defined, if they're not to be disintermediated as bitpipe providers by physical aggregators and the UDF providers you were just describing, Caroline.
And I think we've got some examples, haven't we, of operators that we think are going to be in that camp.
Absolutely. Sorry. Yes, so here we have just a few examples in the very large group of operators who we think are currently doing quite well out of their business as usual mobile broadband models and perhaps just starting to think about what their next steps will be, but we would expect them to wait for some considerable time before they set off on that journey to the summit.
Indeed, and we're also seeing a number of operators with strong enterprise businesses starting the hard climb towards the 6G summit now, heading out for Camp 1, the industrial connectivity platform, as an interim revenue-generating step en route to the UDF. This group of operators is starting to deploy 5G standalone in the cloud, experiment with dynamic slicing, investigate network convergence, the joining up of fixed wireless and transport networks, and work out how edge and IoT fit into their industrial connectivity and indeed industrial metaverse strategies. This group is putting components of the ICP in place, but they need a comprehensive vision and software-defined service platforms to bring that industrial metaverse to life.
And one operator is striking out in front on the path to the consumer-facing metaverse, really pioneering the implementation of many of the software-defined and cloud networking capabilities that we expect to underpin the UDF. Rakuten, Japan, we've currently got it still at base camp, and in some ways its early commercial model has been very conventional, but its architecture is very revolutionary. And Rakuten has various routes they can take with that very flexible architecture they've developed. So they may also pivot to the industrial connectivity platform on a route of its own. Certainly an operator to watch, whichever direction it goes in. And
although we can't yet categorize the path that hyperscalers are on towards 6G and the UDF, we expect them to play a large role as physical infrastructure builders and aggregators, and increasingly, potentially, service platform providers. So with all this in mind, Caroline, I think we've got some recommendations for operators.
Indeed. Sorry. Slides are playing up a little. Yes, we have 3 recommendations. So this all may seem futuristic in some ways, but work is already underway to define the use cases and business models, as well as the underlying standards, so operators don't be left out of the conversation. The 3D internet could be wholly defined and shaped by cloud, internet or enterprise players, and certainly a host of stakeholders will and should participate in driving the fabric forward to reality. But operators must take a proactive and significant role to ensure that the fabric aligns with their commercial objectives. 2, the universal digital fabric won't happen overnight, but operators need to start planning a roadmap that aligns with their business models and provides them with growth and return on investment at each stage from now until 2030. That means putting pieces into place iteratively, first to enhance the 5G case and then to prepare for 6G, in the context of platforms and services, not just networks. A key challenge is to define your targeted role in the evolving value chain that we've described today on each stage of the climb, whether you opt to go to the industrial connectivity platform first or straight to the universal digital fabric at some future date. So, for instance, telcos whose business models have always relied on massive scale may prefer to focus on aggregation, which will become even more critical to ensure that industrial connectivity does indeed evolve into a global platform to enable connectivity through a whole supply chain, and then to evolve further to be part of that global ubiquitous fabric. In any case, make sure that everything you have is open access, API enabled, and capable of being included in the fabric at any stage as it evolves, without significant re-engineering. And finally, there will be many stakeholders and many new competitors, But remember that telcos do have many inherent advantages in the 3D internet. Leverage those existing strengths that will be important in the new world. To name a few, expertise in supply chain control across global device ecosystems, in optimizing connectivity on a global scale while also micro-billing, in massive device management, and in interworking with partners, networks, and services. These advantages have the potential to enable operators to take a significant role in the 3D internet value chain. That concludes our presentation today. I hope you found it interesting, and I'll hand back to David.
Thank you very much, Caroline and Caroline, for that really informative presentation. And thank you to everyone who has tuned in and attended this session. Before you go, I'll just quickly remind you that you can download and access some useful resources. You can still submit questions to our presenters. They will pick up those in the coming days by email. And feel free to now make your way back to the event homepage, where you'll be automatically redirected and where you can choose another session. So we hope you enjoyed this session, and we look forward to welcoming you to another Summit session very shortly. Thank you again.